Hi guys, today we're going to do AS and we're going to do thermochemistry, or in the syllabus it's called chemical energetics. Okay, chemical here means for chemical changes, which means chemical reagents must be it's called a system actually. Okay, there's reagents, reactants, and give you products. Okay, that means there must be a change, right, in the equation. Okay, energetics deals with energy, and here we talk about heat energy. Basically, heat energy. Okay, now. Okay, so two terms here. I'll put it in blue so you can see clearly. So two terms here, right? Enthalpy, which is H. Entropy, which is S. Now, enthalpy is taught in Form 5, Form 4, and it is the heat content, okay, right? You will learn this in lower 6 now, okay? S entropy, you learn in upper 6, which is A2, okay? It's an AS. So we are dealing with only enthalpy, heat change, right? So when there is this case here, this is the enthalpy of H of reagents, enthalpy reactants, enthalpy of products. So the change, the delta H here, right? The change, this is called change. Eh? Change means, well, you're going to be enthalpy, total enthalpy of summation of enthalpy of products minus summation of enthalpy of reactants. Now, this is called, later you see, is called here, enthalpy change of a reaction. Okay, so, and of course, the standard conditions is you have here you put a sign here like that. Okay, so this sign is called standard. Okay, and of course, standard here means the conditions, the temperature and the pressure. Okay, right? Is 25 degrees centigrade. Pressure is 1 atmosphere. It's very important, these two conditions. And for heat, for enthalpy, entropy, and Gibbs free energy, the temperature is 25 degrees centigrade. Why? Because from here, like everyday users, you know the states. The states are very important because when you change the states, you need heat, solid, liquid, and gas. But for gas laws, right? For P equals nRT, right? Boyle's law, Charles' law, which we done, and Dalton's law. Okay, the standard STP, right? Standard. The word standard here, right? Standard temperature and pressure refers to temperature equals how much? 0 degrees centigrade. Now I'm going to show you here, right? This is your data booklet, right here. See, for molar volume of gases. So see the STP, and this RTP, right? This RTP. RTP is 25 degrees centigrade. Okay, 1 atmosphere. STP here, see, STP, right, is 0 degrees centigrade now. See, must be careful. Okay, so for thermochemistry, standard, okay, refers to temperature how much? 25. Okay, but gas is 0 degrees centigrade. So it's very important to make sure this differentiation occurs in the definitions. Okay, now I'll go to quickly here. All right, I'll just something down here first. Okay, now here you have got explain chemical reactions. That means there must be a reactant and a product accompanied by heat energy changes, meaning heat change here. Okay, so principally heat energy change. Okay, now exothermic and endothermic, very important. Exothermic means heat is given out. Okay, right? Endothermic means heat is taken in, absorbed. Heat is absorbed. When do you absorb heat? When you want to break a bond. Why? When you break a bond, heat is absorbed. Basically, because let's say in a covalent bond, right, hydrogen is shared. The electron is shared, so it's stable. It's a duplet. So to break the bond, I need to get that 2H here dot plus okay, 2H. Okay. So heat is absorbed. That means H here is positive. I need to take in heat to break the bond. when I form the bonds, right? If we go backwards here, form bonds, it means it becomes stable. Duplet stable, isn't it? Right? Duplet stable, so heat is given out. So exothermic means negative. Okay. So this is when bonds are formed. Bonds are formed, whether covalent or ionic, doesn't matter. Endothermic means when bonds are broken. Okay, bonds are broken. This is a key thing you need to know. Okay, now before we do this one here, many of this topic here is all calculations. So to do the calculations, we have the few things we need to do. Right, it's just not math simply calculate. Okay, a lot of maths here, but here they want you to know specific definitions here. Explain. Right, and use the term. Explain means it's a specific definition. Here, the first one, of course, is right, enthalpy change of reaction. I just go through it first. They ask you for definition. Don't ask you for definition for and standard conditions. I just told you here, right? What does it mean? Temperature equals how much? 25 degrees centigrade. Pressure is how much? 1 atmosphere. That means normal pressure. Okay. Now there are a few important things here. The first one, second one, the third one is heat of formation. It's called heat of formation. 3. 4, heat of combustion. Okay. 4. Now I won't talk about the rest of here because I want to use just a few, just to not to confuse you so much. We're going to use a few and we're going to use it properly. Okay. Right. Okay. Now here's one more here, which here, Hess Law. Okay. Hess Law here. See, apply Hess Law. What is Hess Law? They also ask you for a definition of Hess Law. Okay, to construct simple energy cycles that are very important here. Okay, and carry out calculations involving such cycles. Calculations, this is the key. Today we hope to finish many calculations here to see how it's being done. So I'm going to show you them how to use the energy cycle. First of all, there are 3 ways of doing this: energy cycle, energy level, and of course simultaneous equation, which I'm not going to do that one. This is more important because it explains to you how it works. Okay. Okay, and relevant energy terms, right? So here you can see, right? Now here, the 2 things they say: determine the enthalpy changes, right? It can be found by direct experiment. Now, of course, direct experiment means a bomb calorimeter. See, in chemistry, there's a way to measure it directly for a reaction. Let's say, for example, carbon plus oxygen. Okay, right? You can put carbon into a bomb calorimeter, you heat it, and you put oxygen in, and boom, it will explode. Measure the temperature before and after, you can calculate the heat by what? Delta H equals to mc theta. Okay, but some reactions you cannot do like that. For example, how do you make methane? C plus 2H2 to form methane. You cannot. You can't just put carbon and heat with hydrogen, and you can't form it. So, or C plus 2Cl2 give you CCl4. Cannot form. So you do by other ways, which is done by the energy cycle. Okay, so indirect. Now the 2, they will ask you together. Okay, 2. One, of course, is heat of formation, which we're going to talk about, enthalpy change of heat of formation. We're going to look at this here. Okay, right here. So there's 3 here. We're going to look at the definition. What does it mean? And enthalpy change of combustion. Okay, here, combustion. What does it mean? So these 2 we're going to use together with your Hess Law, and to calculate for what they want is the the heat of reaction. Okay, so let's go straight into this. Okay, now, all right. So now let's see here first. Okay, remember I told you that, right? To break bonds, okay, it's always endothermic, absorb heat. To form bonds, heat is always given out, exothermic. Standard conditions means what? 25 degrees centigrade and pressure 1 atmosphere. Now they actually ask you. Let me show you the two things here. They ask you. One, of course, is standard, and of course, it comes together with this thing called heat of reaction. I'll show you the question and give you the answer provided by CIE in the marking sim. Okay, so that you can learn from there straight away. Okay, all right. That's in page 78. Now here. Chemical reactions are accompanied by enthalpy changes. Means what? Enthalpy means that heat changes, means delta H. Change, enthalpy, okay? Heat changes. Explain the meaning of the term standard enthalpy change reaction, okay? Now the word standard here. Okay, now let's see it. 2 marks, 1 mark for the standard, 1 mark for standard, 1 mark for the enthalpy of reaction. A reaction here means general reaction, anything general, any reaction, any system, anything with reagents, your products, right, is called a reaction as well. No specific definition. Okay, now, right? Let's see here. Okay, now here, the first one you can do by yourself. Not very keen. It's the second one. Okay, now let's say for example, I give you a reaction here. Okay, you learn in Form 5, HCl equals plus NaOH equals, okay, give you of course your NaCl equals plus H2O liquid. Yeah. Now this is called a reaction. So you put down here, now in Form you learn a specific term called heat of what? Neutralization. Right? Now this is very specific. Okay, it's not talk about acid and base here, but I can put it general. Delta H of a reaction, that's all. Okay, so if I put the sign here, which means the condition is what? Temperature 25 degrees centigrade. Okay, this means sign here means what? 25 degrees centigrade, and the pressure is 1 atmosphere, that's all. Okay, so in this case here, this is this equation, of course, is equal to minus 57 kilojoules per mole. This is what you learn in Form 5, isn't it? Okay, this is the fixed amount. Right, so here in this equation, of course, I can put, let's say, another one, H2SO4 equals plus 2 moles of NaOH equals balance, must be balance, okay? And a 2SO4 equals plus 2H2O. Now, this is also called the heat of reaction without being specific. It's actually equal to 2 times the heat of what? Neutralization. Okay. Now, which means if I call them a reaction here, it will have to go according to the stoichiometry, the number of moles here. It's 1 mole here and 2 moles here to form 1 mole here and 2 moles here. That means here, see the enthalpy change. Means here, okay, when the amount or number of moles, the best thing when the number of moles, okay, number of moles better. Number of moles of reactants, right? React, of course, if they jumble in here, reacts to give you, to react together here better, okay, to give you the number of moles, okay, of products represented as shown in this one is better here, as shown in the equation, better here to be last year. I think for me it's better lah. So enthalpy change when the number of moles of reactants react together to give you number of moles of products as shown in the equation. This is the enthalpy change. This is called the heat of a reaction. Very simple, isn't it? It will go according to the stoichiometry. Here is 1 mole, 1 mole. Okay, give you 1 mole, 1 mole. Now this is called heat of reaction. Here, okay. I put red color so you can see clearly. Okay, red color, right? Now this is called the heat of reaction. It's also called the heat of neutralization. In this case here, this is 1 mole with 2 moles, 1 mole with 2 moles here. This, I can also say this whole equation is heat of reaction. But it's equals to 2 times the heat of neutralization. See now? So heat of reaction here tells you the number of moles of the reactants and the number of moles products according to the equation. That's why equation is very important. Okay, different equation will give you different values. Okay, so heat of reaction is general. Okay, now this is 1 mark. This is 1 mark now. Okay, so memorize it. What is heat of reaction? Enthalpy change when the number of moles of reactants react to give the number of moles of products as shown in the equation. Okay, so the keyword is number of moles of reactants, 1 here, number of moles of products, 2 here, and as shown in equation 3 here. So 3 points get 1 mark. Okay, and second one, of course, measure at some conditions. It's mark 2 here, mark 1, mark 2. Yeah. Okay, now here better still to state it. Temperature equals to 25 degrees centigrade, pressure equals to 1 atmosphere. Better to say it like here. See all the time, see, okay, here. See again, see, under standard conditions. 1 mark. See, maybe quoted, better to quote it because they don't know what the marking scheme is. See, right here again. See, right now here they actually ask you what is the limit standard here. 1 mark. See, 1 mark. So make sure you know the value. Say it, don't care, because here they actually ask you. They ask you here. Say again. All right. Okay. I show you the standard. Okay, it's 28. The question is come to page 28. Okay. See here. What is explain what is meant by standard now? Which means you can state it. Better to state all the time. Whenever you look at this sign here, this little sign here, this one here, it means standard. Okay, right? This is called standard. Okay, right. Now let's go further to look at all the definitions. Okay, right, and see how we can apply it. Right. Now here you can see in my notes here, right? This is something you have to remember very clearly from the beginning. See, elements. In chemistry, there's elements and there's what? Compounds. Okay? Elements are all the things you found in your periodic table. Right? Standard conditions means how they exist. For example, oxygen is O. But standard condition is O2. That means you use this symbol. And it will gas here. So the standard conditions tells you the formula, okay, of the element and also the states. Two things. Hydrogen elements is H, right? Standard condition is what? H2 and what? Gas, Important is sodium is Na, right? Now, standard condition is solid. So these terms are very important, and they say that all elements, don't care what they are, under standard conditions, is taken to have 0 enthalpy. Very important. This is very important later when I do the second part of this thing. This is very important when you draw the energy level diagram. Okay, energy level diagram. This is very important. Okay, it doesn't work anymore. Okay, do it again. Okay, right? See, later we won't do some first. Okay, now let's look at the first one. The first definition. Heat of formation. Okay, now this is very common question. Well, this is from a book. I'm not so smart as to come up with great answers. Okay, but I show you the marking scheme and show you what they look for. Heat of formation. Now is F here, right? This is change, right? Enthalpy change, standard conditions. F means formation already. Okay, F. Okay, of a compound. Had to be for compound because we're talking about formation. It's a heat change, okay, which is delta H. When one mole of a compound, here very important, the first mark is here. Okay, it's formed from its elements. Remember, second mark here. Under standard conditions, 3 marks here. Let's see now here. For example, here, they will give you this equation, this value here. Okay, heat of formation of carbon dioxide. Okay, is equal to -393 kilojoules. Always kilojoules are very important because entropy is joules only. Okay, most kilojoules per mole. So remember, you first of all write the product for CO2. Okay, this will tell you the product. Okay, or the compound form. Okay, compound form. So 1 mole. Why gas? Standard conditions. Okay, compound form 1 mole. Here must be 1. So 2. From what? Elements. What elements? Carbon and O. But there must be what? Standard conditions here. So it's O2. And gas. And here must be solid. Here must be 1. Here don't have to be 1. Here don't have to be 1. Okay. So now this is the equation here. This is the equation here. So this equation very important. The balancing, the formulas, and the stoichiometry. 1 mole, 1 mole, 1 mole here is very important. Okay. Now here the formation of MgO. I don't know what the value. Okay, I can find out myself. Okay. Right. So I put MgO first. 1 mole here. Solid. Okay. MgO2 gas. I must put half it to balance off because there's only 1 here. Now this is for your ethanol. Right. 1 mole here. This liquid here. 1 mole here. 1 mole of the compound form from its elements. There are 3 elements here. Okay. Now we are not God, so we can't do this. So they assume that this is what is happening from the elements carbon, hydrogen, and oxygen. Now, this of course cannot be done. This can be done in the labs. It can be done, but this cannot be done. So we do it by what we call Hess Law later. Okay, it's a theoretical way of doing things. A liquid here. Okay, this is a value here. So you balance again here. 2 carbon here, put 2 here. 6 hydrogen here, put 3 here. 1 oxygen, half here. Okay, right. So this have to always be 1 mole. Okay, here doesn't matter. Here the balance equation have to follow your thing here. Now let me show you how they ask in exams, and of course what the answers are for. 28. Let's see. 28. Do okay. See what is meant by the standard. See standards now, which means here must be the thing here. Right, 25 degrees centigrade, and pressure equals to 1 atmosphere. And temperatures of formations, give you here of a compound, made by standard conditions. Again, here is the answer. I think it's the answer. No, it's on here. Not this one. Okay, here. Here. See, enthalpy change or heat change or energy change when 1 mole of the compound, 1 mole of compound, first mark here, is formed from its elements. Okay, under whole thing to 1 mark now. 1 mark. Same conditions, 1 mark. So 2 marks here. Okay, so this is the way you answer it. It's a heat change or energy change, and 1 mole of the compound is formed from its elements at standard conditions. Okay, right? So this got done by heart on this one here. Okay, now second one, I won't delete that, okay, because I need a lot of time. Second one of heat of combustion. Look at it again. Okay, I give you here from a book. Right? We won't go to thermochemistry first, with the combustion first, because I want to hurry up to let you see how you put the whole thing together. This is combustion. Okay, normally it's delta H. Okay, this change is standard. Okay, this is combustion. It means you burn something of a substance. It can be element or compound. Both can be. So a substance is a general term. The heat evolved. Normally it's given out. Normally it is negative. You burn something, heat is given out. When 1 mole of the substance. Now this earlier for formation, you talk about the products. 1 mole of the compound. Okay, this is 1 mole of the element of the substance. That means the reagent. Okay, here talks about the product. Okay, 1 mole of the substance is completely burned. It's completely burned. Very important. Okay, it means no halfway. In excess oxygen under certain conditions. Now here, right? Here the combustion of carbon. They don't put a carbon here. Okay, it's on here. So we start with this one here. Here must be 1 mole. Okay, excess oxygen. You cannot form carbon monoxide. Must be carbon dioxide. Okay, so balance of solid, gas, states must be always there. Okay, right? So this is the heat. Now this equation also same as the formation of carbon dioxide. See now? Same. So this the RC one. These two are the same. The value is the same. Just the name are different. The equation are the same. Okay. Now you burn one as a heat of combustion of methane minus 890. So here must be 1 mole of methane. 1 mole here. Okay. And you have to construct the equation. Carbon dioxide. Remember complete that. No carbon monoxide. Okay. Plus water. Put the states all there. The balance of there's 4 hydrogens here for total of 2 and 2, 4 oxygen here. Okay, so give on here. So this is the equation. And 1 mole here, 1 mole here, 1 mole here. Now here the combustion of ethanol. 1 mole here. Okay, and you give you the carbon dioxide and water here. Right. So 2 carbons here, 6 hydrogen here. Put 3 here. So here's 6 plus 1, 7. So it's 2 plus 4 plus 3. Balance it. So this is the heat of combustion. Okay, so with these 2 definitions of specific reactions, combustion and formation, and 1 more, then we go to all our calculations again today. It's quite interesting. Okay, we won't do this on Hess Law. Hess Law. Now, the Hess Law is basically for reactions that you cannot use a bomb calorimeter, a direct route. This is an indirect route of achieving things. Okay, so Hess Law states that, right, the energy change or the heat change or the enthalpy change. Okay, in converting reactants A plus B to product C plus D. Better to use a, now I know that the Cambridge will give you a thing from reagents to products, but better because we are like this now, A plus B to give you C plus D. This is more, I don't know, I find it easier to look at some examples, okay? Can be A, B, C, and C, A, B, C, and D, E, F, whatever, okay? It's the same, that means the change here is the same regardless of the route in which the chemical change occurs. Now, normally there are 2 routes here, 3 routes or 4 routes. So here's the direct route, can also go to here, go to E, and this one go to F. Then E plus F will give you C and D, okay? So this is called, I can go to Seremban to KL, direct route by the highway, or I can go to Seremban to Mantin, and then to Semunyi, and then to Kajang, and then to KL. So there are 2 routes there. So see, the energy change is the same. See, energy change is, that means here is, let's say, delta H1. Okay, this is delta H2, delta H3, this is delta H4. Hess law says, right now, the energy change in converting reagents A plus B to C plus C is the same regardless of the route. Very important now. So it's converting reagents to product regardless of the route by which the chemical change occurs, providing the initial and final condition are the same. So what's the initial? From Seremban. Final, Kuala Lumpur. Okay. So in this case here, you got A to E, B to F, E and F to C and D is the same as A and B to C and D. Okay, that means these 2 remain the same. So by Hess law, I say that, well, delta H, okay, 1 is equals to this root here, the heat change is delta H2 plus delta H3 plus delta H4. So equal means the quantity, the quantitative, the amount here is the same, I can calculate. Okay, right? Now let's look at the definition given here. Here, okay, here from, okay, formation. Now, here, okay. Now this one here. All right. Enthalpy change for converting. See now, enthalpy change is a Hess law, okay? Converting reactants, okay, into products. Of course, I say reactants A plus B to C plus D. Okay, it's the same, regardless. It's the same regardless of the route taken. I will have to add a provided what? Provided the initial and final conditions are the same. Okay, so 2 marks here, 1 mark for energy change for converting A reagents to products, A plus B to C plus D. Right, second mark is the same regardless of route taken. This one here is just to give you an overall perspective, that's all. Okay, right. Now next one, of course, I forgot to tell you over here, the combustion. I don't know why I didn't do it first. Here, the combustion. I just remembered from here. Okay, here. Oh, yeah, I did. Right. Now I'll show you the, I forgot to tell you, to give you the question in the past question. Okay, never mind. 36, 36. Okay, completely burnt. 36, here we are. See, define the term standard again, enthalpy change of combustion. Okay, right, now here is the Cambridge one. Okay, here, sorry, here, right here. Sorry, not here. Okay, here. The enthalpy change, heat change when 1 mole, of the substance, which means here is the reagents, is burned in excess or completely combusted. Burn in excess, okay, undergo complete combustion. That means it cannot stop halfway. Like carbon cannot give you carbon monoxide, it's give you carbon dioxide unless you have combustion of carbon monoxide. Okay, see, under certain conditions, 1 mark, always. Okay, all right, this whole thing here is 1 mark. Enthalpy change when 1 mole of a substance is completely burned under certain conditions. Yeah. Okay, all right. So now with these 4 things in mind, we're going to look at a few challenging, I guess, challenging way of applying all these things, okay? Because that is in an easier way, okay? I'll page 33 first. Okay, no, I think I'll start with here, sorry. Start with this one, the easy one first. Page 4. This one here. All right, now we're going to use the whole thing now slowly. So you have to bear in mind, I didn't go through all these things now here. Okay, simple question here. Calculate, I'm going to rub it off first so I can use this right here easier, okay? I'm going to draw for you the energy cycle. Very important, because the question will ask you energy cycle, and of course the marking scheme will say the cycle is 1 mark. Okay? Right? I show you the cycle is 1 mark. I should say that. Rub this off first. All right. I think it's here. Energy cycle. Don't know why I keep on coming up. Okay. Just show you the word cycle there. This one here. This one here. I think it's on here. I don't know where is it now. My later lah. Okay. Now here, the question is calculate the heat of formation. Okay. Of carbon monoxide now, which is right halfway. Given the heat of combustion of carbon. Okay. Combustion means complete, no, give carbon dioxide. The combustion of carbon monoxide. So always start with the question. Okay, formation. It means a carbon formation means that go to carbon monoxide gas. It must be 1 mole. Okay, 1 mole, right? Formed from its elements carbon and oxygen. Okay, so it must be O2 here because at what standard conditions? So it's gas here and solid here. Is it balanced? No, I put half here. Okay, so now this is called your heat of formation of carbon monoxide standard. Okay, I want to find what's this value here. So I'm given these 2 things here. Now these 2 things, first of all, before I put in the cycle here, I want to convert these to equation first. Combustion means carbons plus oxygen. Gives you what? Carbon dioxide. Why? Because combustion means what? Excess not fully combusted. Cannot halfway. Okay, so it's solid here, and of course it's what? Gas here, and this gas here. Is it balanced? Why? Yes. Now this is delta H equals to how much? This carbon standard equals to how much? Minus 393. I forget this was okay. And this combustion for carbon monoxide means 1 mole carbon monoxide, gas plus oxygen. Gas give you what? Carbon dioxide. Yes. Delta H of combustion equals to minus 283. Cannot. Now a balance of here will be half. Okay. Right. So I must put these 2 here into this whole thing to create an energy cycle. Called energy what? Cycle. Okay. So what can I do? Of course, I can go this one here, I can start with applying this one. Okay, carbon, I want to go to carbon dioxide from here, from this part here, okay, to carbon dioxide. If I go here, I must balance the equation. It means that this one carbon plus, of course, see, here is 1 mole, isn't it? Here is half a mole, isn't it? So I must put another half oxygen here. Yes, that means I neglect some here. I pretend I didn't see some here. Put green color, okay? Okay. Right. Pretend this is not there. Okay. That means here to here, right? 1 mole of carbon plus 1 mole of oxygen here, half plus half gives you CO2 now. And this is minus 393. Now whatever I put on this side here, I must put here plus half O2, a balance of. Okay. So now this is root here, this root here. Now how about from here to here? Cannot. Okay, normally cannot. So carbon monoxide plus oxygen here is the second here. Okay. So I start from here, only here. So it's what is minus 283 because one more now. No, one more there. One more there. So so I've created what you call a cycle. See now, right? Okay. So Hess law says that initial root A and root B is the same. So what's the first root? All right. Now follow the arrow. Right? Now you can do this is the first root. Let me see here. I put red, okay? To make it easy for you. Okay. Now this is root 1. Root A. Root B is first arrow here to here and here to here. Now, it means it contains 2. This is root B. Here, root B. So in this case here, initial and final condition are the same. Initial is what? Here. Sorry, here. Final is here. So I got Swaramban, Kajang, and KL. Here, Swaramban to KL straight away. Okay, so by Hess law, what are heat changes? Okay, so first, okay, right, which is minus 393 equals to, now, since one more, I keep it 1 here. If it's 2, it means I must times 2 here. Okay, so here is delta H of formation. Okay, plus this value here. So plus I must put bracket because it's minus here, minus 283. See now, right? So I can put delta H, delta F is equals to minus 393. Bring over minus 283. Therefore, I can calculate it. It's not. Understand? So this is the answer. Okay, you work out the answer. All right, 393. Okay, and here, sorry, 393. I should glance earlier. I know 283. Okay, equals to, right? So the minus is bigger. Is plus is minus 110 kilojoules. Remember, kilojoules per mole. Very important to put the sign here. Okay, the sign here and the unit here for the 1 mark. Cannot. So how to compose this whole thing is a skill which you need to learn. I won't dilly-dally with all these things. I will go straight to the point. Okay, now you want me to do that, or maybe do one more. Okay, let's do one more. Never mind. We go straight to the point. Okay, there's no time. I finish in half an hour. Okay, the first one is page 33. We do straight away the passive question. Okay, now. So here it says explain the standard enthalpy change of formation. Can you say when 1 mole, right? 1 mole of the substance is formed from its elements at standard condition. 3 marks here. So the marking scheme is here. I just show you. Is it? Here is not. Some here. Here. Okay. Right. Okay. Well, when 1 mole of the compound, 1 mark, formed from its elements at standard conditions. Okay. Right. Okay. Under standard conditions. Okay. Okay. Here. 3 marks. Right. So sometimes only this thing is only 1 mark. No. And this 1 mark. It's always 1 mark on standard conditions. Quote it. Temperature goes to what? 25. Pressure goes to what? 1 atmosphere. Easy busy. Okay, now this is the part we talk about here. Okay, now here, calculate the standard enthalpy change of formation of this called carbon disulfide. This is actually a well-known liquid, okay, to dissolve plastics, all these things there. Okay, never mind. So first of all, you have to write equation for all these chemical changes. Okay, now the first one here. Enthalpy change of formation, information is in, okay, which means actually I think I'll write it the last, okay, because all this have to be written because otherwise you cannot balance equation. Okay, and the standard enthalpy change for formation, okay, which means what? Here, formation means that 1 mole of your SO2, right, from its elements sulfur and oxygen. Now this is a skill you have to learn. Standard means what? This is gas, sulfur dioxide is gas, and this solid, okay, must O2. Balance not? Balance perfectly. Now this I put the delta H is equals to the formation here. I can put all these things here, okay, now, minus 298, okay, now, right? Secondly, of course, here is standard enthalpy change of formation for CO2, okay? So CO formation again, 1 more of the compound, CO2, gas. From its elements, carbon plus oxygen, O2, remember? This is gas. Why? Because it's standard solid. Here's what? Delta H of formation of what? Standard. Normally they put a CO2 here now, okay? Normally, and of course here put SO2 here. Equals how much? Minus 395. The one, standard here, combustion. That means I must start this one first. One more of the substance, okay? One more of the compound. CS2, this liquid, okay? Burn in excess oxygen. That means I must have complete combustion. O2 to give you what? Carbon monoxide. As carbon dioxide cannot be carbon monoxide, okay? Gas. Why gas? Standard conditions plus what? SO2. Now must balance it. This is also gas here. 2 sulfur. So 2 here. Okay? So 2 now I must balance my oxygen as gas, okay? So 2 here is 2. How much oxygen? Here is 2 plus 4. Right, 4. So I must 3 here. Understand? Right? So now I've done this. So now I got to write in the question here. Okay? Right? Now, so here I got first I must write the equation for the problem formation. Okay, we'll put in blue color. Okay, so it's easier for you to distinguish. Okay. Okay. Now here, equation give me 1 mole of carbon disulfide liquid. Okay, right? So here form from its elements. Okay, here formation is it. Carbon, I put over here because I want to use the space here. Sulfur. I don't use S8. I can use S8, but forget it. Put 2 here. Solid here. Solid here. Okay, now this is called the heat of formation. Okay, formation. I want standard. So all must be standard here. Because we don't know. Okay, so how to get the 3 marks here? Okay, now I must fit in all these things into this cycle, Hess Law. So the first thing I want to put is, of course, sulfur. Okay, now I'm going to use the green color so that it can be distinguished easily. Okay, so I don't care about my carbon first, just on sulfur alone. Okay, just on sulfur alone. Now sulfur here. Sulfur plus oxygen. I imagine I just put sulfur and oxygen here. O2 gas. They will give you what? Sulfur dioxide. I must comply with the 2 moles here. So it's 2 moles here, 2 here, 2. So must be 2 here to give you 2 here. That is the equation. Okay. So now this value here must be what? So I got here 2 times minus what? 298. Here. Okay. Now when I put the 2 moles of here, I must put here the 2 moles of O2 gas. I must balance off the whole equation here because everything must be nicely balanced out. Okay, now can I also go do for example carbon? Can, right? Carbon 1 mole here plus O2, so I plus O2 here. Yes, to give what? Carbon dioxide. Here 1 mole, is it? So the heat given is here. So I do the times of minus 395. Okay, I'm going to do it slowly so you can see how it's all happening. So now this is my compound. See now. So the last, of course, is this one here I applied. So now I put O here, I must plus O2 here. See now interesting is always correct one. See, the total number of moles here is how much? 3 moles here, right? 3 moles O2. Now do you think here? See, 3 moles O2 here, nicely. And 1 more of this one here, nicely. So from here, it gives you 1 more carbon dioxide, 2 moles of sulfur dioxide. Yeah, that means from here to here is another route. See, right? So Hess Law. Now follow the arrow. Okay, this part here I'm going to use purple color. Okay, so it's nice to have all the colors. Purple color. Okay. Means from here, this route here to this route here, right? This is the route, right? From this one here, I can also go to here by the second route. I use another color here. Okay, I use black color, brown color better. Okay, see, I go from here. Ayo, tak boleh lah. Tak boleh. Okay, again. Okay, here, follow the arrow to here. Okay, that means here like that. Okay, so this is a route 2. Initial and final condition are the same. So how do I write it down to get the answer? Very simple. Okay, let's start with this root first. Okay, this root. Okay. Okay, so it's delta H formation plus what? Plus this one here. Now here, of course, I forgot to put down the value here. This one is delta H of the combustion. Okay, then quickly down here, minus 1110. Okay, so here is what? Minus 1110, because 1 mole. So it's this one here. Okay, that plus minus 1110. Put the bracket always equals to how much? These two further here. Okay, plus here plus here. Yeah. So equals to minus 395 plus 2 times minus 298. It's not. Okay. So your delta F equals to minus 395 plus 2 minus 298. You bring it over, is minus 1110. It's not. Of course, the answer, I done it here, okay, is equals to plus 119 kilojoules per mole. Now look at the marking scheme. Very important, look at the marking scheme, because otherwise you don't know where you go wrong. Okay, see now. Okay, now, see now, minus 2 times, minus 3.7, okay, 3, what is that? Yeah, see? Oh, wrong one, 0.5, I got the wrong, what's wrong with you? 0.4, 0.5, 0.5. Sorry, I don't know why I didn't do it, okay. Okay, 0.5 November 2, now I look at it, okay, 0.5 November 2, 0.5 November 2, 0.5 November 2, 0.5 November 2, 0.5 November 2. I'm going to hurry. I got the wrong one. 0.5 November 2, 0.5 November 2, 0.5, 0.5 number 2, 0.5 number 2. Coming. 0.5 number 2, 0.5. Okay, it's up here. See, I thought I got it there, but I didn't. Sorry about that. 0.5 number 2. Okay, here we are. 0.5 number 2. Okay, here. Okay. Very important to check the marking scheme, right? Because otherwise you don't know how they mark so that you will score. You want to score maximum marks now. Okay. Now here is it. Okay. See now. Okay. Now. Right. See. The answer is what? Oh, sorry. Here. Draw. See. See now. Okay. Right. Now cycle is not cycle. 1 mark. Okay. Now look at the cycle. Okay. Cycle. This whole thing. When draw this whole thing, it's 1 mark. Okay, cycle. This one I didn't find. Okay, cycle mark. Right. Use of 2 times. 2 times of sulfur dioxide. Yeah. Which means here, this see, it's not okay. Right. 2 times. Okay. 2 times this. Okay, 1 mark. 2 times that. See that. This one here. 2 times this. 1 mark. Cycle mark. 2 times this 1 mark. See. Which means you understood. See that? Okay? Right? Answer 1 mark. So 3 marks here. See that? 1 mark for cycle, 1 mark for 2 times the 1 here, 1 mark for the answer. Okay? The rest of them, I mean, you can get an answer right. It means the rest of them is correct. Okay? So the 2 times the value here is 1 mark. See that? Okay? Okay? Okay. This is 33 here. Now let's look at another one. 15 to 20 minutes more. Okay, to page 39. 39. Okay, another one here. Right? Right? Now, carbon, hydrogen, and ethane each burn exothermically in excess air. It means they heat of combustion. Right? Now here, all these are heat of combustion. C here. Right? C here means actually combustion as well. I'm going to put red color so better. Okay. More distinguished. Okay. Heat of combustion, it means 1 mole of carbon, 1 mole of hydrogen burn complete, half mole of oxygen here. See, all the states are given as standard condition. 1 mole of ethene, C2H4, okay, gas, one here, 1 mole. Okay, you can see they all balance and they did for you very nicely. Sometimes they don't give the equation, you have to do it yourself. Okay, so use the data to calculate standard heat of change of formation. Okay, even though this they give very good. It means 1 mole here of your ethene from its elements now, right? Which is this one here, carbon and hydrogen here. And it's all balanced nicely for you. So how do you use this to form the cycle? Same thing. It means you look at this, okay, what is all do with combustion? It means I need to put oxygen to finish it. Normally it's combustion and formation. Normally these two, so I say I better do that first. Don't talk about the others, okay? Right? So here I start with, of course, carbon. Okay, to carbon combust with oxygen. Okay, now. So 2 moles here, I must plus over here. Okay, 2, I got 2O2 gas. Why 2? Because here's 1 mole here, 2 here, 2 here, 2 here. So the first thing it will give you is 2 moles of CO2 gas. And how much is heat? Now 2 times, got mark 2 times minus 393.7. Okay, so I put 2 here, I must put plus 2 here. 2 moles of O2 here gas. Now, hydrogen can also burn, okay, right? I put plus, I can put over here the plus, okay? So here's 2, I times 2 here, I times 2 here, I times 2 here. So here will be O2. Can put here what? So here give what? Give you 2H2O liquid, okay? So plus here. So here's how much? Times 2, is it? That's 1, is it? So it's here it will be 2 times what? Minus 285.9. They're very cruel. Put the point here. Here I also must put down here plus O2. Okay? Whatever I put here, I must put it here. So it all balanced. Now, fantastic, isn't it? See? Just on this side here, isn't it same as this one? 3 moles of 3 moles here. So 2 plus 1 is 3 there. That means here go to here. So this whole thing is same as here. See, 2 moles are coming outside. See, fantastic. It will all form a nice cycle. It's called energy cycle. Okay, here's how much? For 1 mole, isn't it? 1 mole. So it's what? Minus 1411.0. That means that they want accuracy to 0.1. 0.0. Okay, so the root, follow the arrow. This one here to this one here, follow the arrow. Okay, Chinese quite soon. Okay, so this 2 equals to this one plus 1 here. Okay, now this one here, of course, this is called the heat of formation. Okay, formation. Okay, so I put down here, I use them first. Okay, delta H. So I put a by Hess Law. Normally I put by Hess Law. Okay, because you use Hess Law. So it's delta H of formation. Okay, plus bracket minus 1411.0. Okay, equals to 2 times minus 393.7 plus 2 times, always put minus here. Okay, put a plus here, put a bracket here. Okay, 285.9. Then of course the delta H formation equals to, put 2 times minus 393.7 plus 2 times minus, before you do any calculation, don't do first, okay? Put all this down first, because the mark is given for all these things here. Minus 1411.0. Then calculate here, 3 marks. Now look at the marking scheme. I think I got it down here. Okay, right, see that, right? Of course, the answer here is down here. See that, 2 times minus 393.6. Okay, see here. Yeah, 2, see that here. Okay, 2 times minus 285.9. Okay, right here. And then minus, see, minus 1411. Minus 1411. Okay, so this is, so when you see this, well, they will give the mark already, Where is the Gundu? Okay, now let's see how. Okay, now when all positive, okay, when you get the answer, mark plus 51.8, okay, you can do it out. It's equal to plus 51.8. See now, the must be accurate to the decimal point. There's accuracy here, kilojoules per mole. Okay, so this is the answer here, right? So now remember here, look at the marking scheme, right? Say penalize no 2, see the times 2 is important one. Okay, times 2 important one. It means that this one times 2 mark here, times 2 mark here, okay? And then the answer is 1 mark. Okay, units. Okay, so 3 marks, 1, 2, 3, 3 marks. Very simple. Times 2, the value here, okay, wrong sign also, wrong sign, okay? They penalize, miss here. Okay, it means the marks 1, 2, 3, this one here. Okay, right? So number here. Can? Okay. Now next question here. I've got 15 more minutes. I'm trying to do as many as possible, my friends. 43. Oh no, 77. I'm going to do 2 the objective questions to see how to show you how devious these fellas are. Okay. Now here they didn't give you the equation. The table gives you some heat and enthalpy change for combustion. So you must know what's combustion already. Okay, for carbon, for hydrogen. Now here, of course, you write out the equation. CS plus O2 combustion must be full combustion. Give you what? Carbon dioxide gas. What I put the delta H. Okay, I won't. There's no place to write out. Minus 393.5. Okay, no. I won't put the, of course, kilojoules per mole. Okay, this one here, hydrogen is H2, balance, 1 mole of O2, plus this gas here, plus it be half O2, right, to give you what? H2O liquid. How much is this? Minus 285.8. That one, of course, is now this is a propanol. Don't care which formula is it, don't care. 3H7OH liquid, they put liquid here for you, plus O2. Now balance yourself first. Let's say, okay, give you no place here. Carbon dioxide, remember complete combustion, okay? Complete, fully combusted gas plus, of course, your H2O. Okay, now let's balance it. 3 carbon, so 3 here. Okay, 8 hydrogen here was 4 here. Not too good. Okay, put nicely. Plus here, so 4. This is a liquid. Cannot, right? So here now you need to balance the oxygen. Here is 6. 3 plus times 2 is 6. 6 plus 4 is 10. Right? 10. So here it's got 1 here. 1 here, see, so 10 here be 9, 9 is it? So it's 4.5, isn't it? So I very bad. Erase. Okay, let's put it again. All right. So here is 4.5. Okay, I put a plus here. 4.5. Why 4.5? Right? Because here is 3 times 2 is 6, isn't it? 6 plus here 4, isn't it? Right? That's 4. 10 is it? 10O. But he got 1 already, what? See that? So here was 9, is it? Okay, to give this one here. So 1 more here. How much? What is this? Here is minus 2021.0. Remember accuracy here, right? So now how to put it all together? Very simple, okay. So I put down a bit here. So all is combustion. It means I must combust. Okay, carbon, hydrogen, and there's oxygen here and combustion. That means first I must combust. So I do carbon first plus O2. Okay, so 3 moles, right? 3 moles in. So times 3, so 3, and of course with 3 here and 3 here and 3 here. So it's 3 moles here, right? To give you what? 3 moles of carbon dioxide. Then times what? Remember not? 3 times I got the mark on, no? 3 times what? Minus 393.5. Okay, now I put 3 moles here. I must put the plus 3 moles here. O2 gas. Okay, now hydrogen. Remember, there's only half here. I didn't use this half line. Okay, now hydrogen 4. If it's 4 here, I'm going to put blue color so you can see clearly. Blue color. Okay, so remember if I put 4 here, times 4, right? Times 4 here. So if I half times 4, or half times 4 times half, it's equal to 2, isn't it? Right? 2, right? So here should be 2, right? So here should be 2, right? So so I say 4. Sorry, this next is hopeless. 4, 8, isn't it? So here's 4 here. 2 times 2 is 4. Yeah. Now here, so it's already half here. Okay. So if it's already half here, right? I must I need what? I need how much? Yeah, a bit confused here. Okay, I need 2 here. So it's I must plus what? Plus 1.5, isn't it? Okay, O2. Yeah, because 1.5 plus half is equal to what? 2O2. Okay, which is here 2O2. Okay, so I must start here 1.5 O2 gas. Yeah. Okay. So a total of here how much here? 4.5 O2, which is exactly the same as here. See? So here, of course, plus your water, which is 4 moles of H2O liquid. So here to here, right? This for 1 mole. So it's 4 times minus 285.8. That's all. So now from this part here, this whole part here to here, see that? Same as it. 3 moles of CO2, 3 moles of CO2. 4 moles of water, 4 moles of water. Ah, fantastic. So what's the heat change here? Remember this one here. See now, for 1 mole, see now, 1 mole here. So it's how much? Minus 2021.0. So by Hess law, so now this is whole cycle, no? See? Now they of course give you some more space, which is excellent. Okay. See? Currently heat of formation of zone. Yeah? Means right now. Means this one here. Okay, never use the space here. So remember the root 1 here to here to here. Okay, now this is the first root or second, whatever lah. This root here and here. Okay, so we use this root. Okay, this root here. So it's delta H formation, right? Plus bracket minus 2021.0 equals to how much? This one here. 3 times minus 393.5. Okay? Plus what? 4 and minus 285.8. So your delta HF is equals to, see, all this working is important. Once you get this, you get a mark already. So make sure you do all these things here. 0.5 plus 4 minus 285.8. Bring this over here, minus 2021.0. Okay, now let's look at the marking. Okay, and then you can calculate it. The answer is I did it here. Let me see. Is equals to minus 302.7 kilojoules per mole. Members, 2 things. The sign and the units. Okay, now let's look at the marking scheme here. I think I got it here. Yeah, see now. Okay, so the cycle, see now, 3 times this one here, 1 mark. Okay, right? This is 1 plus 1 plus 3, isn't it? 4 times here, 1 mark. This is, see, normally the cycle is 1 mark. See now, see, but they all not good. Put gas, okay, put liquid here. See now, okay, the cycles now. This is it. Okay, now of course, now the answer here. Now 5 marks on this question, fantastic, isn't it? See, right? So remember 3 times this one, okay? So the 3, now the 3 here and the 4 here, see now, okay? 3 and the 4 here, 3 here and the 4 here. See 3 here and the 4 here. Put this down first. The mark is given for that, okay? Right? The mark is here already. See now, okay? So it's 5 marks for this question, fantastic, isn't it? So okay, see now, see, here's 2 marks. 1 mark for this one here, 1 mark for the answer. And here 1 mark for the cycle, 1 mark for the 3 times this one, and 4 times this one. Okay. I don't know which one to give it, but normally the cycle is 1 mark. Okay. Now let's quickly do about 5 more minutes. Let's do the objective question. Objective is quite hard. No, they see this 5 marks. In objective is 1 mark. It's quite unfair. Okay. Objective 75. 75. Okay. Now there are 2 questions here. Okay. Now we do this one first. Okay. By time we do that one. Okay. Okay. Methaldehyde. So here. Now there's 4 here. Okay. If you don't know it, this is 4 here. It's used as a solid for camping stoves. Okay. Equation of the combustion. So I'll give you here. All right. Okay. All right. I think I would. Okay. To make it easier, I want to use this here. Okay, I'll put a bit bigger so you can see clearly. Okay. Okay, right? Okay. Because no time really. Right. Use red color. Okay. Red color. No, it's orange. Red color. Okay. Right? It's used to stove, blah blah blah. This is the heat. This of course is the heat of what? Combustion. Okay. Short. Right? Okay. You burn in excess oxygen, give carbon dioxide and water. See carbon dioxide and water here. Now, which expression will give the correct value for the heat of formation? Formation of the of methaldehyde. Now it's see okay here. I'm gonna do it here. Okay, right? Formation, right? I see I can make it bigger so that I can use more space now. Okay. Actually, I got another place, but I cannot. I say I can use. I want to use all these things so it's easy for you to see. Now, now we do it here. Okay, do it here. Right? Okay. Remember this CH3COH. Okay. Okay. CH3CHO. Bracket 4. Yeah. See carefully, right? So I do make solid, isn't it? Solid here. Heat of formation means what? I form from what? I form from carbon plus hydrogen plus oxygen. Total how many carbons here? 2 times 4 is 8. So it's solid here. Hydrogen how many? 4 times 4, then 4 times 4 is 16. So it's 8 here. Oxygen is 1 here, so 4 is 2 here. So it's gas. Understand now? Okay, now this is the heat of what? Heat of formation. This is what they want. Okay? Why not? Heat of formation. See? Which expression will give you the correct expression for heat of formation? Okay. Now they gave you a few things here. Combustion of carbon. Okay? Combustion of carbon, combustion of hydrogen, right? And combustion of methaldehyde. Okay? Which means they have all combustion are very simple. So I need to finish the whole thing by combustion. Okay, I combust carbon first plus O2 gas to give you carbon dioxide. Okay, so it's 8 here, 8 here. So 8 here, so it'll be 8 here now. Okay, because if you talk about here, if you want to do the whole thing also can no? Carbon solid here, no time that's all O2 gas give you CO2 gas. This is your heat of what? Combustion of carbon. Okay, so it's 8 here, so I put times 8 here, 8 here, 8 here. Yeah, okay, so this was 8 times what? Heat of combustion of what? Of carbon. Oops, hurry. Let me see. Okay, heat of combustion of carbon. Okay, now, which is here. Okay, right? C, okay, or put carbon now, okay. Number, okay. So, okay, now put, that was put 8 here, 8 moles of oxygen here. Okay, now for hydrogen here, I put blue color so can see easily. Blue color, okay, right? Hydrogen here, of course you put the real one is H2 gas plus half O2 gas. Okay, give H2O to get So one more with here. So 8 moles with 8 times 8 here, right? It'll be 4, no, and here will be 4, isn't it? Okay. So here, right? Now remember here is already 2. I need to add just 2 more plus 2 of O2. Total is how much? 4, isn't it? Right? This here is what I didn't use here. So here we give what? 8 moles of H2O liquid here. So this is 8 times what? Delta H of what? Combustion of hydrogen. Right? So plus 2 here, I must plus 2 here. O2. Right? So total is how much? 10. Now if I look at this one here, if I combust here, CH3, CHO plus O2 here for the okay now. If a bracket here is 4. I think they give you here. See, they give you here. See, is here 10 moles here. See 10? Fantastic. Fantastic, isn't it? So it's easy for you. So see 10, a total of 10 here. So here to here plus 10. See now, 8 and 8 now. Yeah, 8 carbon dioxide. See? See? Right? So the root 1 here to here. So what is it? I put down here. So delta H of formation plus, now here to here is a what? Heat of what? Combustion of your CH3, CHO, and 4. No, plus plus your delta H of combustion of CH3, CHO bracket 4 equals to this plus this 8 of combustion, delta H of combustion of carbon plus the heat of delta H of combustion of hydrogen. Right? So heat of formation, right, of the meth aldehyde is equals to 8 times delta H of combustion of carbon plus 8 times delta H of combustion of hydrogen, right? Minus delta H of what? CH3, CHO bracket 4. See now? So what's the answer? Obviously, D. See? Understood? Okay? And I've got no more time. Okay? You can try the others yourself now. Okay? So we have done how to calculate using Hess law, using heat of combustion, heat of formation, and heat of reaction and standard conditions. Okay, now, okay. So you can see here. I don't know. Stop. Stop. Stop it.